we're doing rational exponents. So what I want you to realize is we're still dealing with exponents. Okay, the only difference is what? What do you notice about the exponents? It's a fraction now. Okay, so we have to understand what that fraction represents, and that's this. Okay, so it has to do with square root and an exponent. But I want you to think of something. We call this a root, a square root, right? Or a cube root, or a fourth root, fifth root, sixth root. It can be anything. Okay, the keyword though is root. That's what they all have in common. Where are roots of a tree? On the bottom. So the bottom number is your root. Okay? That is your root. Okay, the top number is your exponent. So if you look at this one, we know that my base is 8, so I'm going to have that inside of a house of a root. And what root do I have? So this is a cube root, and it's to the second power. Okay, if you notice, these should be on your desk. These will benefit you greatly in this unit. I want you to realize roots cancel whatever they are. So this is a cube root, which means it cancels cubes. So we want to find something cubed that equals 8. What cubed equals 8? 2 cubed. So when I rewrite this to 2 cubed, the cube root cancels the cubed, and I end up with just 2 squared. Well, what is 2 squared? Four. Okay, so let's look at number 2. So same concept. Our root is on the bottom, so this is going to be a square root. Now, with a square root, do you have to put the 2? You don't, because this is a square root. We call that a square root, right? Unless it has a number that tells us differently. So I want you to realize when it's a square root, if you just have the house, that's okay too. Okay? So knowing that, we have 36. Well, 36, what squared is 36?
6.
Ooh, why can't I find it? There it is. Okay, 6 squared is 36. So square root cancels the squared. And I can get 6 to the third power, which you can also find on here is equal to what?
216.
216. Okay.
Wait, does this involve I for the next one?
No.
Okay.
So if you look at number 3, there's a negative. Okay, and can you square root a negative?
No.
No, but you can cube root it. If your root is negative, odd, then it's allowed to be negative on the inside. It won't be imaginary. Okay, if it's an even number, 2, 4, 6, 8, it's not going to work. It's going to be imaginary. Okay, and the reason being is because think about it. A negative times a negative equals a positive. So there's no way to cancel 2, 4, 6, 8 if it's negative. You see what I'm saying? Now, a negative times a negative is a positive, times another negative is a negative again, and that's why the odd numbers work with negative. So this is okay. So we're going to rewrite it. This is the cube root to the fourth power. Well, what gives us, I'm going to put that negative, what gives us 216? That's cubed. So 6 cubed is 216, meaning the cube root cancels the cubed, and I'm left with negative 6 to the fourth power. Well, I want you to think about it again. My pink calculator is not working. Negative 6 to the fourth power is going to give you a big number, but I want you to realize it's a positive number. Okay? You could have found that also on here. 6 to the fourth power is 1,296.
So it works because they're odd numbers?
Because your root was odd.
Okay, so if it's an even, like if it was 4,
It would be imaginary.
Imaginary?
Mm-hmm.
Okay.
So we have another example. So just remember, if m, no, sorry, not m. If n is odd, negatives are okay. If n is even, negatives, we'll say negative bases. Negative bases are going to be imaginary.
What is that little detail? Negatives.
Negative bases are okay. So if n is odd, negative bases are okay. If n is even, negative bases will be imaginary.
So you want to put the negative?
So we'll get to an example, I promise. Okay. So this is an example of it being odd. It worked out and it's fine. Okay, let's look at this one. What's the difference in number 4? It has a negative exponent. So just a reminder, that means that we're going to have to flip something, but let's just set it up first. So we're always going to give that negative to the top. Okay? So let's go ahead. This is the third root, cube root to the negative 2 power, and we need to figure out what cubed gives us 64. Well, 4 cubed equals 64. Cube root cancels the cubed, and I get 4 to the negative 2 power. Now, who remembers the rule with a negative exponent?
It has to flip.
It has to flip. It's on the wrong side of a fraction. So if it's not a fraction already, we have to make it a fraction. This whole thing has a negative exponent, therefore it needs to move down. And when I move it down, it becomes a positive 2. Now, can the top of this fraction be empty?
Nope, it has to be at least 1.
So put a 1, and 4 squared equals 16.
Very unique way of doing it.
Okay, so let's look at number 5. Here nothing changes. The whole thing is in the negative 3/4 parentheses. So we're going to write it. This is a 4th root. And it's going to be to the negative 3 degree. Now, we need to find what to the 4th power equals 256. Well, if you look in the 4th power, 256 is 4 to the 4th power. Over 625 is 5 to the 4th power. So this cube root cancels both sets of 4's, and we end up getting 4 over 5 to the negative 3 power. Right, Jesse? You awake? Just making sure. Okay, so I want you to realize technically this has a power of 1 and this has a power of 1. And so we are going to multiply that in, because power to a power, you multiply the powers. And we get 4 to the negative 3 power over 5 to the negative 3 power.
But then they have to flip because
They both have to move because they're both negative. So this needs to move to the bottom, and this needs to move to the top. And we end up with 5 cubed over 4 cubed, because remember, once we move them, they're positive. 5 cubed is 125. 4 cubed is 64.
So will we have to round it down if it's possible, or can we just
If it's possible. Okay, so those are done. Let's look at number 6. Now, this one's set up a little differently, but I want you to realize nothing changes. I want you to realize their roots are what? They're the same. They're both cube roots, right? Therefore, we can combine them. Well, another way to write division is with a fraction. So I'm going to cancel this and move it down. And then since they both have a cube root, I can put them under the same house. And simplify. What's 88 divided by 11? 8. So when I rewrite this as cube root of 8, well, 8 is a perfect, 2 cubed is a perfect, is 8. So this just equals 2, because 2 cubed, cube root cancels the cubed, and it equals 2. Now, I realize that this step is kind of tedious, but I'm putting it there so you understand. If you don't need to show that step, that's fine. Okay? So if example 6, if we can combine the division under one house, do you think we can combine the multiplication? As long as the roots are the same? Yes. Because neither of these are perfect roots, but when we combine them, 81 times 9 gives me 729. So is that a perfect cube?
Yes.
It is. 9 cubed equals 729. So the cube root cancels the cubed, and it equals 9.
Mrs. Cumbridge,
Yes.
that yellow piece of paper, do you have that on your
I
website?
I will, and I also have some outside if you pick up a packet, but I will be posting it online as well.
Okay.
Yeah. Remind me after the lesson, and I'll do it right then.
Okay.
Okay, so example 8. What's my root? 2. So this is just a square root of 36. Does the first power change anything?
No.
No, so what's the square root of 36?
6.
Well, 6 squared,
And then it equals
so it just equals 6. So like I said, this is the step that if you don't need to show it, I understand. Okay, now what do you notice about number 9 and number 10?
one has the parentheses.
Yeah, they're exactly the same, but I don't know if y'all remember yesterday I kept saying parentheses change everything. Okay, and they do. So I want you to realize that this one, the negative can stay on the outside because it's not telling you it has to be on the inside. So I want you to read this is a square root of 49 cubed. But see, I put the negative on the outside. This one, however, is telling me that the negative has to stay with the 49. So it's set up the same way, except it has a negative on the inside. But this is a square root. Can you take the square root of a negative? No. So let's finish this one. What's the square root of 49?
7.
So I get
7.
7 cubed is 343. So this equals negative 343. Now here, technically, if I want to keep going, I get 7i to the third power, which gives me 343i. So yes, they're close to the same, but they mean something very, very different because negative 343 is a real number, 343i is imaginary. Okay, so if you write not real, that's fine too. I just wanted to prove to you that they are very, very similar. There can be, yes. But do you notice that my root is an even number? That's why it became imaginary. Okay, so you do have to show all of your work on this practice.